Welcome. Let's solve the following log equations. Let's take a look at example A. The variable that we're looking for, which is x, it is inside the log function. When we have this situation, we have a strategy. What we will do, we're going to rewrite the log equation as an exponential. So let's do that. Let's start by getting the base of the log, which is 4, and let's raise it to the value that we're equal to, which is 3. And now that exponent will always be equal to the inside of the log, which in this case is x plus 2. And now that we have written it as an exponential, it is easier to solve for x. The only thing that needs to be done is to subtract 2 to both sides. And now we're going to get x by itself. Let's calculate that value. It is equivalent to 62. Let's take a look at our next example. Let's start by identifying where is the variable of x. It is inside the log on the left, and it is also inside the log on the right-hand side of the equation. But this is a very special case. The log on the left, it has a base of 3, and the log of the right, it also has a base of 3. When we have this scenario, we can just set the insides of the logs equivalent to each other. So now we're just going to get 7x plus 3 equal to 5x plus 9. And now we can solve for x. Let's start by subtracting 5 to both sides. Then let's subtract 3 to both sides. And let's divide it by 2. Now we got our value of 3. So just a reminder, anytime that we're solving and the left-hand side and the right-hand side are using the same base of the log, we can just set the insides equal to each other. Now let's take a look at example C. Let's start by identifying the location of x. It is inside the evaluation of the first log, and it is also inside the evaluation of this second log. When we have more than 2 log expressions, what we would like to do, we would like to compress the expression. And this is the case. We got 1, 2, and 3 log expressions. There is a way for us to combine these 2 log expressions. We can apply the product rule. In the product rule, it says anytime that we have 2 logs that are adding to each other, we can look at the inside of each of those individually. And then we can write it as a single log, just multiplying the inside. In our example, the expressions on the insides are going to be x minus 2 and x plus 3. So let's apply this rule. Let's write it as a single log. And now the right-hand side, let's just bring that down. And now we have the same case as our previous example. There is 1 log on the left, and there is only 1 log on the right-hand side of the equation. They both share the same base. We can just set the insides equal to each other. And now we can start solving for x. Let's expand the left-hand side. Let's start by distributing the variable of x, and we're going to get x squared plus 3x. And now let's distribute this negative 2. And then we're going to get negative 2x minus 6. The right-hand side, let's bring that down. Let's combine any like terms on the left, which is 3x and negative 2x. That's going to give us just positive x. And to solve for x, let's set the equation equal to 0. Let's subtract 14 on the left and the right. So now we have a trinomial where the highest exponent is 2. Let's try to solve this by using factoring. So let's think of 2 numbers that when we multiply them, it is equivalent to negative 20. And when we add them up, it is equivalent to positive 1. Let's organize our thoughts. And those 2 numbers are going to be 5 and negative 4. When we multiply 5 times negative 4, it does give us negative 20. And these two same numbers, if we add them up, it does give us positive 1. So now that we have those values, now we can rewrite our expression as x plus 5 times x minus 4. And now we can set each expression equal to 0. On the equation on the left, let's take away 5 to both sides. And now we got one solution, x is equivalent to negative 5. And on the right-hand side, let's add 4. Then we have that x is equivalent to positive 4. Now let's check for extraneous solution. When we consider the value of x equals negative 5, notice that when we plug it in here, in our first expression, that's going to give us a problem. We are going to end up with a negative inside the log. We can never evaluate a negative number inside of a log, so we're not going to consider this value. And now when we check our value of x equals 4, there is no problem, because when we plug it into the first expression, 4 minus 2, it is positive 2, that's okay, it's a positive. And when we plug it into the second, 4 plus 3, that is equals to 7, it is still a positive, so that is good. So therefore, the only solution, it is x is equivalent to 4. Let's take a look at our next example. So here we have the same situation as before. There are multiple logs, one on the left and two on the right. Let's try to think about, can we compress any of those sides, either the left or the right? On the right side, we are subtracting 2 logs. We can apply the quotient rule. The quotient rule says when we have 2 logs and they are being subtracted, that is equivalent to just write it as a single log, but we will divide the insides of the logs that we're subtracting, which in this case is x plus 2 and the value of 3. So let's apply the quotient rule. The left-hand side, let's just bring that down. And the right-hand side, we're going to get x plus 2 on the numerator and 3 on the denominator. So now this is good, because now we only have 1 log on the left and 1 log on the right. And then in addition, they both share the same base. So what we can do, we can just set the insides be equivalent to each other. So we will get 2x minus 1, and that is going to be equal to x plus 2 divided by 3. Now let's solve this equation. I'm going to start by dividing the left-hand side by 1. And when we do that, we can think of cross multiplication. And now we're going to get 1 times x plus 2, and that is going to be equal to 3 times 2x minus 1. And when we multiply the left-hand side, we're only going to get x plus 2, and let's distribute on the right-hand side. The first distribution is going to give us 6x, and the second distribution is going to give us minus 3. Now let's take away 6x to both sides. When we combine like terms, that is going to give us negative 5x. And if we want to solve for x, we got to get rid of that plus 2. So let's do the opposite. Let's subtract 2 on the left and the right. And that is going to give us negative 5. Now to get x by itself, let's divide it by negative 5 on the left and the right. So now we have our solution. Now let's check if 1 can be used as a solution. When we plug in 1 in this expression, we're going to get 2 minus 1. That is a positive number, so we know we're good. And if we plug in x equals 1 in the inside of this log, we're going to get 1 plus 2, which is 3. That is still positive, so there will be no problem. When we plug in 1 inside the logs, we do not end up with any negative, so we know that x plus 1, it can be used. Let's take a look at our last example. Let's start by identifying where x is located at. X is inside, but we're not evaluating by log anymore. We are evaluating by the natural log, ln. We can still use the same strategies as we did before. But there's one thing that we should consider. The base of ln, it is the Euler number. And because we only have one ln, then we can apply the same strategy as we did in our first example. Let's write it as an exponential. Let's get e as the base of my exponential. And now let's raise that to the third. And let's set that equal to the inside of ln, which is 4x minus 1. Now let's solve for x. Let's start by adding 1 to both sides. And now let's divide it by 4. And now let's use our calculator to find this value. To access the Euler number in our calculator, notice that it's here in blue. So what we will do, we're going to press second and then the Euler number. And to that, let's raise it to the third. That is going to give us a value of approximately 20. Let's add 1 to it. That is the value of my numerator. Now let's divide that by 4. And we get our solution, 5.27. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.